Committee of this webinar to welcome Dr. R. Sarda Jayalakshmi Devi, Honorable Vice Chancellor and Chief Patron of this webinar, Dr. A. Vishnuvardhan Reddy, Special Officer, Dr. G. Karunasagar, Dean of Agriculture and Principal Investigator IDP, and Dr. A. Mani, Dean of Agricultural Engineering and Technology, who are working as patrons of this webinar, and also the other participants and speakers of the webinar to participate in this today's webinar, and I heartily welcome all to the webinar. And coming to the webinar,
Very good afternoon, dear participants. Very shortly, we will be continuing with the webinar. There are little technical issues. Solving them very shortly, we will be starting with the webinar. Thank you.
Dr. Vimla, madam, you can continue.
okay, madam. So coming to the today's webinar on advances in food technology, we know that the science of food generally covers different aspects of like production, handling, processing, distribution, marketing, and also finally the consumption. As per the report of United Nations, it says that about 1/3 of all food consumption is being wasted every year, and nearly 828 million people don't have enough food. The global food market is also estimated to grow about $342.52 billion by 2027. The advanced food processing technology which is being in operation or which are being practiced today, these will be discussed in today's webinar by two eminent speakers, Dr. P.S. Rao, Professor Agricultural and Food Engineering from IIT Kharagpur, and Dr. P. Narendra Raju, Senior Scientist, Department of Food Science and Technology, NDRI, Karnal. So without any delay, we will start going to the proceedings of today's webinar. Now I request our Dean of Agricultural Engineering and Technology, Dr. Mani Madam, to say a few words about this webinar. I request Mani Madam to speak. Madam unmute చేసుకోరా.
Good afternoon to the elite gathering. Respected Honorable Vice Chancellor Madam Dr. Sardaja Lakshmi Garu, Special Officer Dr. A. Vishnuvardan Reddy Garu, Dean of Agriculture Dr. Karnal Sagar, and Associate Deans of all the colleges and the Faculty of Agriculture Engineering and Technology, and the faculty from all the post-harvest technology centers, my dear students, and all the participants and distinguished speakers of the webinar, Dr. P.S. Rao Garu, Professor Agricultural and Food Engineering, IIT Kharagpur, and Dr. P. Narendra Raju Garu, Senior Scientist, Department of Food Science and Technology, NDRI Karnal. Good afternoon to all of you. I really appreciate the topic that has been selected for today's webinar, advances in food processing technologies. Actually, the food industry is witnessing a major boom in view of the increasing demand for ready to eat and ready to cook processed foods. Rapid urbanization and changing lifestyles and growing population are the main reasons which are leading to the increased demand for more sophisticated, convenient and very available foods. After pandemic, people have become more conscious about their health. As a consequence, preferences towards the kind of food and intake of food has been changed. And food technologies are working on developing healthier alternatives and reducing the content of harmful substances in the processed foods. In the recent years, we have seen so many developments in the food processing technologies that has revolutionized the way we produce the food, the way we distribute the food, and the way we package the food. These innovations are not only enhancing the efficiency and the quality, but also contributing to the sustainability and food security of the food systems. So many novel food technologies have come into the picture in the food industry. To name a few, high pressure processing, pulsed electric field technology, advanced packaging solutions, robotics and automation, and novel food preservation technologies. These are some of the few examples of the transformation innovations that are taking place and which are going to shape the future food industry. And in addition to that, the integration of the digitalization and Industry 4.0 technologies are also playing a major role in advancing these food processing technologies. So these advanced food processing technologies are continue to evolve and become more accessible so that we can expect a more sustainable, efficient and consumer-centric food industry in the years to come, with reduction in the food loss and wastage. So these advanced technologies, we hope that going to address the problems related to global hunger index and the food wastage index, whereas according to the report of 2023, global hunger index is 111. Out of 125 countries, we are standing at 111. And when food wastage index is concerned, we are standing at 101 out of 116 countries concerned. So in the years to come, these advanced food processing technologies will become more accessible and more available so that we can address the challenges related to food security and food wastage. So in this context, I once again appreciate Dr. NTR College of Food Science and Technology for selecting a apt topic for the webinar and selecting a very distinguished faculty speakers for this for the having the knowledge sharing on this topic. I thank Dr. P.S. Rao Garu, our great alumni, for accepting our request to deliver a topic on non-thermal methods of food processing technology. Thank you very much, Dr. P.S. Rao Garu. And I also thank Dr. P. Narendra Raju Garu, Senior Scientist, for accepting our request to deliver a topic on intelligent packaging systems for dairy and food products. And I congratulate the organizers for selecting a good topic and for selecting the distinguished speakers to give a deliberations on this one. Thank you very much for giving me this opportunity.
Thank you, madam. for your continuous encouragement and also appreciation for selection of this topic. Now I request Dr. B.S. Rao, Professor, Agricultural and Food Engineering, IIT Kharagpur, to deliver his topic on non-thermal food processing. And before going into the topic directly, I request Dr. Vimala to introduce the speaker to the audience. Vimala, please.
Good afternoon, respected dignitaries. I am fortunate to introduce Dr. P.S. Rao Garu, Dr. P. Srinivas Rao Garu, who is a professor at Agricultural and Food Engineering Department of Indian Institute of Technology, Kharagpur. Sir is an prestigious alumnus of our institute, ANGRAU. He has done his BTech from Acharya Ranga Agriculture University, and later he has done his higher education from IIT Kharagpur. Presently, sir is serving as a professor, Agricultural and Food Engineering Department. So we are very happy to have Srinivas Rao sir here for this webinar, for giving a lecture on this topic, which is very, very essential for our students. Thank you, sir, for joining with us and accepting our invitation.
So thank you very much for a nice introduction. So good afternoon, one and all. Is my screen visible in full form?
Yes, sir.
Yes, sir, it is visible, sir.
Is it a full screen or any?
It is full screen, sir.
Okay, fine. So good afternoon, respected Vice Chancellor Madam, Dean Sir, Mani Madam, CHV Sir, Anuradha Madam, and all the other faculty colleagues and my dear friends. So good afternoon. Today I'll be discussing on some of the novel non-thermal methods, which actually we have little experience in that particular area. As the webinar is on advances in food technology, so I felt non-thermal processing methods are actually pertinent in this respect. So before getting into the actual topic, so let's understand why actually non-thermal methods. Because we know the thermal processing methods are well established and these are actually being practiced for a quite long time. In spite of having the safety established by non-thermal processing, by destroying the pathogens and spoilage organisms, but they have difficulty in terms of the quality deterioration, where actually the flavor, aroma, nutritive values, these are being compromised because of thermal abuse. So in the today's competitive world, when you would like to meet the world standards, so probably we need to have a quality product, then only probably we'll be able to compete. So here actually the non-thermal methods, maybe it's a pasteurization or maybe sterilization which you are targeting for, but that plays a major role, or maybe that can pave the desire of the consumer who is actually interested in fresh-like and quality products. So the major advantages with some of the novel processing techniques, basically is retention of sensory attributes, and it can retain the desired texture, it can improve the functional properties, where actually it leads to a lot of new range of products, so that actually can give a better marketability to many of the commodities. And similarly, the existing process, thermal processing, is not that energy efficient in spite of a lot of developments in that line, but these novel methods, they are expected to have better energy efficiency too. So when you classify these novel technologies, they are categorized into electro technologies as well as non-thermal technologies. So electro technologies, under this actually we have pulsed electric field, radio frequency heating, microwave heating, infrared heating, ohmic heating, etc., which makes use of the novel methods of heating, although this actually is not considered as a non-thermal, but this novel method of heating can do a kind of quality retention, because the rapid heating actually is actually facilitating the minimum loss of such kind of quality attributes. But when it comes to non-thermal technologies, so we have high hydrostatic pressure processing, pulse light, oscillating magnetic field, osmotic treatment, then CAMA storage, cold plasma, etc. These actually considered as non-thermal and of course which are novel too. So in the non-thermal methods, basically, so they will be inactivating the enzymes as well as microorganisms in order to modify some of the functional properties of the food. And overall, actually, so without actually losing much of its quality, normally, which is happening to you due to your thermal processing. And here, actually, the temperature increment is either negligible or maybe nil. So that's why these are considered as non-thermal processing methods. So when you look at these non-thermal technologies, these are considered like improved food processing technologies. They lead to minimum loss of processed induced color, flavor, texture, and maybe nutritive value. They retain the highest possible quality in a stressful storage environment too. And the products which are resulting in these methods, they are shelf-stable and of course having a fresh-like food attributes. So that means whatever the product which you are preparing through these non-thermal methods, they are like actually fresh-like retaining with the good quality. And of course, this technology can optimize the ration variety by creating some of the novel products. At the same time, this can lead to acceptance and acceptance of the consumer for their consumption without any kind of hesitation. When you list these non-thermal food processing technologies, there are of course several, but out of them actually we will be discussing in brief about these four. First four: high pressure processing, pulse light technology, pulsed high voltage electric fields, and ultrasound. So rest of them are of course are considered as non-thermal, but the paucity of time it limits us to these first four only. Now, when it comes to high pressure processing, this is considered as a novel method of non-thermal processing of food, and it is relatively new in concept and compared to conventional thermal processing. It is receiving wide attention all over the world. So, in fact, it is one of the non-thermal methods which is actually wide applied and maybe commercialized too. So, this is having certain synonyms like hyperbaric pressure processing, ultra high pressure because we are using quite a high pressure, and the pressure is created through some kind of hydrostatic media. Thus, it is also termed as high hydrostatic pressure, and it is also said to be Pascalization. Now, when you look at this process, what is the range of pressure? So, the high pressure processing generally is applied between 100 megapascals to 900 megapascals. So, many of you might not be aware. So, 1 megapascal is equivalent to 10 atmospheres. Thus, this 900 megapascals makes about 9,000 atmospheres, which is actually quite a huge. However, the advantage is this technology can be applied with or without any kind of heating process. That means at ambient condition also this can be applied, and it can achieve the microbial inactivation, or sometimes this can alter the food attributes, creating novel range of intermediates or maybe final products. And that's why the desired quality can be achieved by this technology. So this, as I already mentioned, so this can be applied at ambient temperature. Thereby, we can eliminate any kind of thermally induced cooked off flavors. So high pressure processing can be used both for liquid foods as well as the solid foods, but the food should have little flexibility, and these are to be filled in some kind of flexible containers. And moreover, high pressure processing can also treat the low acid foods. So the treatment of food under high pressure processing is uniform and nearly instantaneous throughout the food product. That means when compared to your thermal processing, wherein the temperature penetration is from outer layer to inner layer, thus the reaching of central core, the required desired temperature, it takes little longer period. Whereas in this case, it's quite uniform and instantaneous. So you can eliminate this time which is delayed because of the come up time. Another important thing is here most common is, as I said, it is a hydrostatic pressure processing. Water actually is commonly used as a compression medium, and this gives lowest heat of compression. So for example, for every 100 megapascals, the liquid water can give 2.8 to 3 degrees centigrade temperature rise. That means if you are applying about 500 megapascals, then it may lead to about 15 degrees temperature rise, and your ambient conditions are nearly 25 or 27. So this will not be crossing more than 50. So that's how actually it is safe in terms of the quality. At the same time, if you are having some kind of microbes like spores, which are high barrier resistant, they may require some augmentation of the temperature. So if you use some kind of lipids like olive oil or maybe soybean oil, they can raise the temperature to the tune of 8.7 to 9.1 degree for every 100 megapascals. So that means here also the same 500 megapascal if you are applying, so probably 45 degrees temperature raise would be there in addition to your ambient condition, thus reaching to the nearly pasteurization temperatures. And this temperature in combination with high pressure can lead to even sterilization in most cases. So that's what is the advantage with the high pressure processing, having different kind of compression mediums. Now, in certain cases, we may even go for below ambient conditions also, like maybe frozen conditions or maybe chilled conditions. Under that situation, the water, if you are using as a compression medium, might get solidified. So that's why we may use alcohol, particularly isopropanol. This is used and which can give about 1.8 to 2.2 degrees centigrade temperature rise as a heat of compression. So that means it will not solidify, but there is a slight temperature rise, which of course will be taken care of overall by circulation of any kind of cold. Now, the advantage is high pressure processing can retain the food quality and natural freshness, thus extending the microbial shelf life. There are a lot of applications for establishing the shelf stable products, blanching, pressure assisted freezing and thawing is another major application. And of course, all of you are aware, freezing actually any food product from a normal ambient condition to its frozen temperature like -80, it may take several hours. But this pressure assisted freezing or thawing takes actually quite a short period. So freezing takes less than 60 minutes, thawing takes only few minutes, which is actually quite a rapid method compared to your traditional thermal methods. Similarly, the pressure assisted extraction is another lucrative process these days. So all of you know solvent extraction, but if you go for pressure assisted extraction, the infusion of this solvent, this is actually quite rapid by improving some kind of microstructure, thus penetrating this solvent rapidly, and at the same time, the solubility of the components also will be made easy. That's why actually we are getting a better quality extracts. And similarly, one more technology is infusion. This infusion is basically penetrating some unavailable nutrients. For example, in a particular food, we don't have vitamin B. If you'd like to infuse, this is possible to infuse in liquid form. Similarly, in case of paneer or maybe other kind of solid foods also, you can have some kind of salted or maybe spicy paneer prepared by this infusion technology, which is actually one of the recent development in Rutgers University, US. And according to the industry estimates, in the coming decade or so, the HPP market is expected to grow a lot, and maybe it may reach about 90 billion per year. So moving further, so this is the simplest what I can say structure of a high pressure system. It's simply a circular vessel having a bottom cap and a top cap. So this bottom cap will be normally fixed, and the top cap is actually movable, and it can be removed, and you put your samples inside. But this sample should be packed in some kind of flexible packaging like LDPE or HDPE, EVOH, PVOH, which are actually kind of specialized packaging material. One can use PET bottles also, but any material which you are using, that should have about 15% flexibility. That is the most important thing. Now, around this vessel, you can see some of the heating and cooling arrangement is there. So whenever you are expecting some temperature rise and you would like to remain with a lower temperature or maybe ambient condition, then of course, this circulation of a cold fluid or maybe hot fluid can be utilized. So that's how actually you can maintain. Now we can see at the bottom, there are two pumps. One is a low pressure oil pump and there is a high pressure pump. This low pressure pump, it will be filling the hydrostatic medium into the vessel. And further, once it is filled, the high pressure pump, it takes over, and this can further pump into the same vessel so that the intended pressure, maybe it is 100, 200 or maybe whatever the pressure, that is actually made up. So once the required pressure is achieved, all the valves which are there, those will be closed. Thus, it is in a holding process. Similar to your thermal processing, after building the required temperature, we are holding for some time. That's called processing time or maybe holding time. Here actually, similar kind of process is there. And we will see the profile in the subsequent slides. Now, for example, here, the major advantages with the high pressure processing is it reduces the microbial activity. It modifies the texture and maybe sensory properties to a certain extent. And these may be towards the beneficial effect of any kind of food product. No off color or maybe flavor development. Thus, it will be as fresh as possible and minimum loss of nutritional value. And of course, we will see some of the examples how the sensitive vitamins or maybe nutrients also will be well retained in the process. Now, some of the possible applications which I mentioned earlier also, and of course, these are some more. Tenderization of meat is one typical example. Manufacturing of purees and jams, sterilization of milk, and NDRI Karnal, of course, they have done some of the studies here at our IIT Kharagpur. And pasteurization of fruit juice. And in fact, Japan is one of the country which is commercializing these pasteurized fruit juices. And instant freezing and thawing, as I already mentioned. But the only difficulty with the high pressure processing is its high capital cost. As on today, the technology is not that matured, and only few companies all over the world, maybe a dozen of companies, they are having a kind of monopoly. That's why the capital cost is still high. But when the technology matures and more manufacturers comes into play, definitely this cost will be coming down, similar to your retard process. Now, moving further, these are some more applications which includes your coagulation and texturization of fish and meat minces, tenderization of meats already I mentioned, and gelatinization of starch is also possible. You can create very soft gels using any kind of protein or maybe starch using high pressure processing technology. And apart from the common techniques, but we are having a sterilization also, it is possible with high pressure processing, which is called pressure assisted thermal processing or maybe thermal assisted high pressure processing. So both are available, where actually you are augmenting your pressure with some kind of temperature, maybe 60 to 70 degrees centigrade combined with a pressure of 400 to 600 megapascal can give a sterilizer point. Okay. Now, these are actually some of the processing conditions people have already optimized for different products. Then, when it comes to the products which are available commercially, so jams, jelly, juices, salad dressings, which I already mentioned, fish and meat products are actually quite common in European countries, and sliced ham too, and rice flakes, and even the yogurt, which is actually quite creamier when you prepare with high pressure treated milk. And beyond that, actually in US, HPP, guacamole, and oysters are actually quite common. So these are actually some of the commercially available products based on the high pressure processing technology. Now, when it comes to the system, so the components of the high pressure system are quite important. And of course, so there are four different major components. A pressure vessel, which I already showed as a vessel, and its enclosure means the top cap and bottom cap. But the same thing in case of industrial system, we will have horizontal vessel, where the side end caps are actually used for closing the system. So once you put your sample inside and close the end caps or maybe top and bottom caps, we will be filling the liquid inside. Then, of course, so this pressurization is done by a specialized pumps, which are actually kind of multi-valve pumps are used for the creation of such huge pressure. So pressure generation system also, it's quite important as far as the system is concerned. Vessel is considered as a heart, whereas the generation system is basically kind of nervous system. So without that, actually, the system cannot work. Then, of course, since slight temperature range is expected, both pressure and temperature are need to be controlled. So there is a control device, which may be SCADA or maybe other kind of technologies are used to precisely control the temperature as well as the pressure. So then we have a material handling system which is required so that the sampling, maybe lowering or maybe raising the sample can be done. So for example, in case of commercial system, there's a horizontal conveyor which will be taking the sample inside the vessel, and thus of course after treatment again it will be taken out. So this way some kind of handling systems are required. Now, as far as the vessel design is concerned, most pressure vessels are prepared from high tensile alloy steels, which are kind of monoblocks. But there are other kind of vessels also like multi-layered. So you will be having a pouring core, and these are called pre-stressed multi-layers. At the same time, you can have a exotic steel as an inner portion, and you can have some kind of wire wounding all around. So this way actually a different type of vessel systems are used so that this can take care of that huge pressure of 900 megapascal. Now, this is one of the commercial systems which is available. It's a 35-liter unit, which is of course vertical in nature. Similarly, we will have horizontal systems, as I mentioned. Is my slides moving? Are my slides moving, sir?
Yes, sir.
Yes, sir.
Okay. So this is actually one of the commercial systems with a 35-liter capacity. Now, the small video just you can watch. This is how actually the HPP technology can pave the way for aquatic products. This is the horizontal system, which is of course moving into the vessel. Then once it is entered into cavity, the whole of the vessel moves inside so that this will be coming across the end caps. So now you can see the end caps are actually closed. Now vessel is being filled with liquid. Then it is hold for some time. Now actually the pressure is being employed. Are you able to see the video?
Only picture, sir.
Okay, just a minute. Now,
Sir?
how is the video is going on?
No, sir.
Okay. Okay, then I will show at the end, okay, separately. So maybe I'll stop it here. Maybe there is some sharing issue, it seems. I will show this video at the end of it. Okay, these are actually the HPP system functions. So now moving further, these are actually some of the commercially available products. So there are a lot of fruit juices which are available. There are some sauces which are created. All these are having some kind of sensitive components where actually the vitamins or minerals, these are well retained. So you can create some kind of healthier foods by having rich in vitamins, antioxidants, etc. So that the higher level of functionality can be obtained in the new products. So for example, the coconut water also is one of the commodity. You can have some kind of spice induced meats, or maybe you can say meat slices which can be made. This is how actually the quality is retained. You can see here the vitamin C at 0, let us say it is having a certain level of 40%, whereas at 540, it is more than 40%. So you may be wondering how actually it is increasing. Normally, these vitamins, etc., these are actually enveloped in a cellular structure. So with the high pressure processing, all these cells, they get ruptured. That's why actually they are exposed and you are getting a higher amount of vitamin C compared to even the untreated one. But when it's folic acid or niacin, you can see even at 540 megapascal, which is quite a high pressure, still the loss of niacin or maybe folic acid is negligible, which is at par with the without any kind of treatment. So that shows the retention of nutritional quality in any of the commodities. Now moving further, so at IIT Kharagpur, we have done some of the high pressure based research on several commodities, starting from lychee, mango, pineapple, even for that matter, coconut water, aloe vera juice. So based on this, actually, these are some of the pictures you can just feel. The first one, let us say it is a control sample, and of course these are peeled lychee. And the last but bottom picture is 300 megapascal and 15 minutes treatment. So even with that high pressure of 300 megapascal for 15 minutes, so there was no color difference. So that indicates that the color is well retained. At the same time, the shelf life could be increased at chilled condition for about 32 days instead of 14 days or maybe 15 days at without treatment condition. Similarly, this is the lychee juice. Here, of course, we have treated up to 668 megapascal for about 15 minutes at 300 megapascal for per minute. This is actually ramp rate, what we call. So at what rate the pressure is increasing? So that's called ramp rate. So here actually compared to the previous one, we are using quite high pressure. So previously it was only 300 megapascal, but here actually we need about 600 megapascal. The reason being, the moment you extract the juice, all the cells are getting ruptured and the enzymes are actually getting activated. So because of this activation of enzyme, inactivating them will be requiring much higher pressure compared to their native state. So that's why actually we require higher pressure compared to the whole fruit for that matter, for inactivating the both enzymes as well as the microbial load. Now this is actually another what I can say process we developed. So for the Amrapali mango pulp, here also actually it's 600 megapascal 20 minutes. If you see the color of this pulp compared to your control, so there's not much color difference. Basically, the color of all fruits, these are well retained, but at the same time, if you are treating some kind of protein-based foods like maybe shrimp or maybe any kind of aquatic products or maybe meat products, so there is a slight color difference. That is because of the protein denaturation. But in case of fruits and vegetables, this will well retain the color during your high pressure process. So that's one major advantage as far as high pressure is concerned. Now moving further, this is actually a pineapple sample. This is untreated, the first one. The next one is high pressure treated with a 50 degrees centigrade combined with 600 megapascal. And the third one is little severe thermal treated, 600 megapascal with 70 degrees centigrade. The fourth one is only thermal processed, set 95 degrees centigrade for about 12 minutes. We can see the influence of the temperature in degrading the quality in terms of color. At the same time, the nutritional value also, it was degrading. So overall, when you see the S2 sample, which is actually 600 megapascal at 50 degrees centigrade for about 30 minutes. So that was actually considered very good in terms of its quality. And of course, so these are actually being decided based on the similarity values. Similarly, this is actually another one on sugarcane juice, where actually the HPP one, you can see the quality is well retained, but thermal treated, although it was initially good, but during your storage, actually there was a huge color difference. So that shows the color stability during your high pressure processing. So overall, when you see the salient findings, the peroxidase, which is actually most baro-resistant enzyme, and aerobic mesophils were most baro-resistant microorganism. However, this baro-resistance of any enzyme or maybe microbe, it determines based on its composition. Some of them will be quite easy to inactivate, and some of the cases it may be quite difficult. Particularly when you are having sugar-bound materials, these are actually difficult to inactivate. So because sugar acts as a protectant as far as the baro-resistance is concerned. And when it is compared with this nutritional quality, the total phenols, ascorbic acid, and antioxidant activity, all of them were well retained up to 50 degrees centigrade within the pressure domain of 300 to 600 megapascal. Overall, when you see the storage study at the optimum condition of 520 megapascal and 50 degrees centigrade, which was the optimized condition for about 10 minutes treatment. So the shelf life would be increased up to 100 days at 4 degrees centigrade storage period. However, the same sample at ambient condition, it was actually only for 25 days. That means it needs chilled conditioning. For that matter, most of these non-thermal methods, they require a chilled condition for the storage. That's one of the difficulty as far as the shelf life is concerned in non-thermal methods. Now, another potential application, as I already mentioned, so pre-treatment before extraction. So compared to your conventional solvent extraction or maybe another thermal hydro distillation technique, here actually if you go for a pre-treatment of HPP before going for extraction, that will facilitate the cellular level what I can say micropores creation, thus the penetration of solvent inside and at the same time coming out of the micella outside, that will be increasing. So this is basically improving the mass transfer, thus facilitating the release of all extracts. And the quality of extracts also, they were found much better. Actually, we have conducted some studies on different what I can say fruit peels and some of the medicinal leaves, etc. So we found actually interesting results based on this one compared to your thermally sensitive components are well retained during your extraction. And at the same time, the extract quality was far superior. Okay. Now, overall, actually, what you can say, so this HPP as a pre-treatment for the extraction is actually is in great demand, and a lot of healthcare functional products are being created using this HPP as a pre-treatment for the extraction technique. So, for example, here you can see the collagen or maybe ginsenoside or maybe anthocyanin. All these are actually extracted using your high pressure processing by different researchers, and it's going to be one of the potential application as far as the health food is concerned. Maybe it is mostly used even by technology industries also. Now, moving further, another important aspect of high pressure processing is the bioaccessibility and bioavailability of micronutrients. So most times actually we may be having the doubt. So compared to your thermal processing, so what happens to your micronutrients? In fact, people found, or maybe you can say, we have a lot of mixed kind of results. Some cases, the bioavailability and bioaccessibility has been improved, particularly carrot, etc. But certain cases, this was not. The reason being, it all depends upon the complex structure of the food. So depending upon the complexity, sometimes this intracellular structural differences are happening, but still it will not facilitate the bioavailability or maybe bioaccessibility. So that's how actually we have to understand for each of the case, so what is the possible what behavior. Secondly, if you are not getting appropriate bioaccessibility or maybe availability, one has to augment with the slight temperature. So thermally induced high pressure processing probably can facilitate or maybe improve this bioavailability. So that's what is the result of some of the existing studies. Overall, you can see that these are actually some of the international markets flooded with a lot of high pressure processed products. But unfortunately, in Indian scenario, still it is in the infancy stage. So only one company, the raw pressury, they are actually producing some of the fruit juices which are generally available in many of the airports at a premium cost, about 250 rupees per, let us say, 250 or 300 ml bottle. So here actually I am not very sure whether the video will work for you again. Are you able to see some video moving? Are you able to see some video? No.
No, sir. No, sir.
Okay. So I think I'll stop here. Maybe share my video screen rather than this one. That's better, I think. Now, are you able to see me?
No, sir, we are not able to see the screen.
Oh, are you able to see now?
Yes, sir.
Yeah.
Yes, sir. Video is running.
Yeah, this is our system, which is at IIT Kharagpur. So this is the control system. This is our high pressure vessel. Is there inside. This is the chiller system for maintaining the temperature. And this is our power pack, where actually several pumps are there inside. That will be able to create that huge pressure of 900 megapascal. So on the screen, actually, you have to set your parameters, starting from what the range of pressure you would like to operate, then what temperature. So this is how actually the touch screen will be displayed. We are mentioning, let's say, 600 megapascal. So after keeping all the data, then the start cycle will be initiating the process. So this is a vessel. Actually, we can get access to this one, and we are now loading the sample inside. We keep a weight so that the sample will not float, because inside we are having liquid. So sample should not float. That's why we are keeping a weight. Close the door. Then of course the process starts. So it takes hardly 5 to 6 minutes to complete the process, and compared to a thermal processing, which requires about 20 to 40 minutes. So now the top vessel, or maybe the top cap is closing. So this is how the whole of the process can be mimicked on the screen. And the entire data will be analyzed, and of course you can get the profile like this. So finally, the top cap will be released, going up now. And you can get the access to the sample. You can see there is no damage to the sample, and of course, the color also almost remains same as the fresh one. Just hold on, just I will show another one how. Is this visible now?
Yes, sir.
Yes. So
Yes,
this is
sir.
the one of the industrial or maybe commercial systems. So the samples are loaded into basket, and that will be going inside a high pressure vessel over a conveyor, and the whole of the vessel will be going inside so that the end caps can close on both sides. The liquid is filled in, and this is actually the pressure is increasing now all around the sample. So after holding for some time, the water is released. That's how the pressure release is happening. Now the sample is taken out, and now this is ready for final packaging. So all of the water which is inside, which was creating the pressure, is coming out now. The sample is taken out, and of course it is going for the next packaging. Similar to our laboratory system, this is a commercial system, vertical, of course. You can see it's a 50-liter system. So after loading the sample, this will go inside, and of course, so this is a crab, which is actually treated as such. Now you can see the meat which is separated out from the crab. Not even a 0% meat is wasted. So complete meat can be separated out, and of course combined with the divide of microbial. That's the interesting thing. Because even from a narrowest leg, you can take out the meat. And now similarly, these are actually kind of shellfish. They're actually normally with a knife, we cook the meat, and the meat loss is almost to 10 to 15%. But when you treat with HPP, so with a simple push of finger, the complete meat can be separated out. So that indicates a kind of facilitation of the meat separation. At the same time, we are getting the microbial load, which is actually removed completely from the mollusk or any kind of shellfish. See, with a simple finger, actually one can remove the meat. So these are some of the marinated fish which are actually treated with HPP for extending the shelf life. So there are a lot of applications. So particularly in case of aquatic or maybe meat products. Okay. So now going back to our presentation. Yeah, I hope the slides are visible now.
Yes, sir.
Yeah. Sure, that's about high pressure processing in a brief way. Otherwise, it takes quite a long time, but I have actually done it in a much brief way. Another technology under non-thermal, which is of course coming up in a big way, is pulsed electric field. We are applying about 70 kilovolt per centimeter voltage or maybe electric pulses between two electrodes, and of course the treatment is only for a few microseconds. So this actually can improve the microbiological safety by inactivating the microbes. Okay. So what is happening normally in any food materials? So there is a transmembrane potential which is normally exist. But when you are keeping this food product between two electrodes and applying the high voltage, so this transmembrane potential is being affected, and whenever you are crossing the electric voltage beyond a particular critical limit, so that actually ruptures or maybe you can say damage your cell. So this damage in cell is basically applicable to even microbes also. So that way the cell damage in microbes occurs and maybe microbial inactivation is occurring. Now, the changes which are actually variety in PEF, and of course, this is actually one of the very old technology which was applied in biotechnology field in the form of electroporation. Basically, they use this electroporation for inserting the foreign DNA so that they can create new creatures. But the same technology now, we are using it for food products where actually the cell rupture is occurring for improving the microbial safety. And if you see the advantages, it will actually remove unwanted bacterial cells without any application of heat. Although practically some temperature rise will be happening due to Joule effect, but that can be actually subsided. So the product remain in its natural state. That means you are actually remaining as fresh as possible. And of course, the treatment actually will be removing all the contaminating organisms. So thus it is actually used in biotechnology field as well as the food processing field also. Now, if you see, the process actually creates some of the pores in the microbial cell membrane, and this electroporation, as I already mentioned, which is common in case of DNA applications. And recently, Japan has developed a HEF-based pilot plant. This is about 200 liters per hour. Actually, they could treat, and there was a 99.9% of inactivation of microbial load, while keeping all the vitamin C intact and of course flavor retention as such. So some of the results, of course, you can see in the subsequent slides. So these are actually some of the changes which happens in various kind of fruit juices, etc. So apple juice, saturation effect has been observed. There's no change in the pH or maybe solid concentration and vitamin C. Sorry. Yeah. Similarly, in case of commercial cheese, so you can get a better flavor and appearance compared to comparable products. In case of pea soup, there was no difference in the sensory properties, indicating that it is as good as the freshly prepared one. And in case of orange juice, which was the same case as I was mentioning, less than 6% of the flavor loss, and of course negligible vitamin C and color change, which indicates the retention capability, the quality retention capability of PEF. Now you can see normally in case of thermal processing, vitamin C, it could have been lost nearly 30 to 50% minimum when you are going for temperatures more than 50 degrees centigrade. But here actually we are able to get negligible vitamin C. Okay. So similar to your HPP, here also there are certain components for the PEF system. As we are applying, it's a 40 to 70 kilovolt per centimeter, we require a high intensity voltage source. And there is a capacitor bank for storing the energy, and there is a switch for completing the circuit, and there is a treatment chamber. So the treatment chamber is nothing but 2 electrodes, and of course covered with some kind of you can say glass or maybe quartz bowl, etc. So that it will create a space for holding the sample. Right now, there are actually several configurations available, and as far as circuits are concerned, so there are 2 different kinds of pulses one can apply. So there is one exponential decay, and another one is square wave pulse. So in case of exponential decay, the circuit is very simple, where actually you are having a high voltage supply, there is a change resistor, there is an array of storage resistors are there, and there is a protective resistor for circuit protection, and this is the treatment chamber, which is basically 2 electrodes. But in this case, because of the tailing effect, there will be some kind of Joule heating effect, which will actually have some implication on the quality. But when you go for this square wave pulse, the circuit is a little complicated with some kind of inductors, which will be making your pulse shape as square and holding the voltage for a little longer period. So in case of the exponential decay, the voltage is decreasing slowly. But in case of square wave pulse, the voltage will shooting up to a peak level, holding it at peak level for some time, and of course going down. So very quickly. So that's actually the Joule heating effect is very, very minimum. But in case of food, industry, the Joule heating is not desirable. So we may go for square wave pulse in most common way. Okay. So another important information is there are 2 difficulties in case of pulse electric field. One is of course arcing. If you are having some kind of gas bubbles present in the food material, that will cause some kind of arcing. And at the same time, if you are having some kind of what I call particulates, so that also creates this kind of attenuation. So these two things are actually difficult in terms of applying this PEF technology to any food material. So that means the food material which is to be treated should be without any kind of gas bubbles, without any kind of particulates. One has to ensure that part. Okay. Then, of course, depending upon your microwave load, depending upon the type of food material, depending upon its pH, depending upon its salinity, we may apply different voltage ranges, and of course, we will be optimizing the whole process. So these are some of the configurations available for continuous chambers of your PEF. And this is the comparison of your HTST process, where it takes quite a long time for completion. Even HTST is considered shortest treatment. But if compared to that one, the PEF treatment with some preheating, they actually quite a short time process. So that's why actually the thermal abuse is minimum and the quality retention is much better in case of your PEF systems. Now, when look at the other non-thermal technique, ultrasound, and of course, many of you might have used, or maybe it is very common in most of the laboratories these days, particularly for emulsification, etc. So there are a lot of applications these days in different areas of food. So particularly extraction, then subsequently for defoaming, even for agglomeration of any kind of particulates or maybe dust materials. For example, you are going for spray drying. So some of the fine particulates might be escaping out from the system, which can be agglomerated and maybe brought back so that the solid loss is minimum. So you can see here, so there are of course different type of systems used. We can apply direct into the food. So by coupling some kind of what I can say transducer, even now you can have some kind of submergence in a ultrasonic bath. So commonly we know, so probe sonicators or maybe ultrasonic bath sonicators, these are the two common systems. But we will have some kind of continuous probe systems also available, where a probe is inserted into a channel and the material will be moving constantly or maybe you can say continuously through a particular pipeline. So at a particular rate. Now, when it's coming to the mechanism of US-induced cell damage, normally any cell which is actually surrounded by your liquid medium like water, so this is influenced by your compression refraction which is created during your ultrasound. So when the ultrasound is applied, so the water which is on the surrounding, that will be penetrating into the cell whenever a compression is happening. So whenever the rarefaction is happening, there is a swelling. So the swelling and maybe this compression, so that will be causing some kind of water or maybe liquid medium influx into the cell. Finally, the cell size will be increasing like a balloon. So when the membrane structure is not able to retain that strength, so ultimately the membrane ruptures and cell lysis occurs. So this is how actually the microbillion activation or maybe enzyme activation generally occurs in case of ultrasound systems. Now these are the actually two common systems, US bath as well as the probe sonicators which are used. But these are actually simple, but the capacity is very small. But when it comes to the large scale systems, there are several developments. This is one 3-liter system for a sono extraction, where actually bioactives extraction is being done with some kind of system, where actually there some kind of jacketed provision is there so that the temperature can be maintained. Similarly, there is a mixing arrangement which is provided so that slowly the entire liquid can be moved inside. Then, of course, these are some of the large scale systems where actually on an existing systems, one can adopt these transducers. For example, here it is a 50-liter system, and this is a 1000-liter system, this is a 500-liter system. On the body of existing mixers, let us say on the body of an existing solvent extraction system, these kind of transducers can be fixed. So that will be causing the vibrations, in turn, causing your better extraction or maybe rapid extraction when you are going for that. Similarly, when you go for the filtration process, we might be using the membrane filters most commonly. So this is one of the membrane processing system without any kind of influence. Probably the substance will be moving on the membrane, and sometimes actually these holes are blocked. Maybe over a period of time, you may need to recondition the filter. Either you replace the filter or maybe you can go for backwash of it. But when you employ this ultrasound, so because of these vibrations, the solids will not be settling or maybe not penetrating into those holes. So that's why the heat, the mass transfer will be improving, and the blocking is delayed. So this way actually you can use the filter for a long time, and at the same time the filtration rate can be improved upon. So this is actually another potential application industrially which is being adopted. Now this is another application which is defoaming. So many of you might be knowing So the carbonated beverages, when they are filled into the bottles or maybe cans, so there's a lot of froth which is generated on the top. So with this situation, the filling will take long time because you have to wait until the foam actually gets subsided. Instead, actually, if you use such kind of radiating surface for some kind of ultrasonic waves creation, so the foam will be subsided. You can fill up to the level very quickly. Similarly, in case of frying also, so when the oil is having high moisture content, so there's a lot of froth which is generated. So that is actually dangerous. So this application, particularly on industrial frying systems, will be a boon for controlling such kind of froth, and you can actually control all this overflowing material. So this is another application which is actually cutting up fragile and sticky products like cake or maybe your what you can say, paneer, etc. So you can have a very clear cut. At the same time, the knife which is being used will not have any kind of adherence of the material. Thus, you can avoid cross-contamination through microbial loads. So this is actually very useful in terms of large-scale industrial cake cutting systems or maybe sticky metal cutting systems. Here actually the blade is actually attached with a ultrasonic probe which will be oscillating. Thus, a clean cut will be there whatever the time you are actually using that one. At the same time, since the metal is not adhering, so it will not have any kind of cross-contamination. Now you can see another very well-known application is your emulsification. So with a classical double emulsion by some kind of agitation, we can create such kind of emulsion where actually larger water particles are surrounded by your oil. But in a ultrasonic assisted double emulsion, we can see large particles are actually now cut into very small particles. Overall, actually, it is a very uniform and uniformly distributed particle size actually one can find. So the emulsion is much more stable compared to your classical double emulsion. So this way, the lot of applications are there in emulsification also. Another, of course, as I said, extraction, it is being used. So this is how actually the cell rupture is occurring when ultrasonication is used. And because of this cell rupture and micro pores creation, the solvent can penetrate into the cell very easily. At the same time, the dissolution is actually done very quickly and maybe in a better way because the solubility also is improved. Overall, the extracts will be taken out from the basil. This is a typical example of the basil. So you can actually extract the essential oils very easily, and maybe the quantity also it is much. That means yields are actually much improved and with a better quality. So that's how actually a number of applications are there based on ultrasonication. And maybe I'll try to close with this pulsar light treatment as the next process. So pulsar light treatment also is one of the potential application for microbial inactivation, particularly the surface decontamination. So many of you are aware, ultraviolet radiation is used for the decontamination, but because of this intensity of the light, it takes a long time. So on a surface, you have to expose ultraviolet light for a couple of minutes or maybe many times actually half an hour or so, so that the decontamination can occur. But food products, when you are having a large volume, so definitely it is difficult to what I can say, wait for half an hour. So there actually the pulsar light treatment, which is very high energy intensive light, although it contains the radiation between ultraviolet to near infrared, but this light is actually 20,000 times higher intensity compared to the solar radiation reaching on the earth. So you can imagine actually what intensity of flashes are there. However, these intense flashes are used for destroying your microorganisms, and the treatment time, or maybe we can say exposure time, is few pulses of microseconds. That means overall the treatment time is very, very small. Now, the microbial inactivation occurs in such a way that 9 log cycle vegetative microorganisms can be removed and on a plane surface without having any kind of what you can say undulations. And in case of bacterial, it's about 7 log cycles one can do, but this is actually applicable to smooth non-porous surfaces of packaging material. But unfortunately, in case of food materials, most of the surfaces are complex and porous. That's why you may get about 2 to 3 log cycles reduction only. However, one can do a multiple sources of light which can be actually exposed, and maybe more number of pulses actually can be adapted, so that this will be useful in terms of the microbial inactivation to the desired level of 5 log cycles. Now, this is a typical system where we need a high voltage power supply here also, because similar to your PEF, here also it requires about 20 to 80 kilovolt power watt. Then we need a energy storage capacitor, and we need a pulse shaping inductor. So this pulse shaping inductor is nothing but the flashlights, how they are glowing. So that can be actually made as per your design. So for example, we are having a series of lamps 1 to 10. All 10 lamps can be flashed at a time, or maybe even lamps can be flashed at a time, and odd lamps can be flashed followed by. The other way, actually, every alternative lamp will be flashing after few seconds of delay. So all this shaping actually can be done by your pulse inductor. This flash lamp, when it is getting the power in that particular form, so this will be flashing accordingly, and the radiation is falling on a particular target, which is nothing but your food material. Either it's a static table, or maybe a conveyor belt. So if it is following a conveyor belt, of course, the system can be used for a continuous treatment system. But if it's a static, probably it's a batch system. So one of such batch system is this one. So like, similar to a microwave. So here actually inside you can keep the sample, close the door, and a few flashes actually can be put onto this one, so that the sample can be sterilized, and of course we can take it out. Okay. However, there is some temperature rise because of continuous flashes, so that can be subsided by circulating some kind of cold air, but it should be sterile. Now these are the lamps, which are this is a kind of lamp array which can be used into the system. This is your power regulator like SMPS, or maybe you can say that programming which one can do. And this is how actually the system can be developed. It's a continuous system where actually on a conveyor belt samples are moving, which are pre-packed, and this is a kind of final sterilization, so that no cross contamination is occurring, or maybe if any cross contamination occurs during your packaging, can be eliminated here. And finally, this is going for the packaging and maybe consumer. Similarly, this is the milk or maybe some kind of liquid products which are filled into the bottles, and where before capping, the top surfaces are being sanitized, so that whatever the contamination is occurring during your filling, that can be eliminated, and the product is actually safe for that. Okay. And this is another system. The whole of the aseptic condition also is created by the lamp array only. This is a lamp array which is actually sterilizing your air, and that air curtain will be used for the aseptic system. And these are actually a number of bottles which are moving on a conveyor belt. And these are actually some of the filling systems. And these LEDs will be glowing, and of course the top surface of the bottling can will be happening. And that's how actually the bottle is sterilized first, followed by filling, and of course capping is done, and of course it's going out. This is one of the US patent for aseptic packaging using light sterilizer of pre-formed product contents. This is actually a container already existing that is sterilized and of course filled in. Now, for designing any system, we require the array lamps. However, these lamps are available in different configurations, starting from a straight or maybe some kind of rounded. You can have even looped, and all these things actually can be used depending upon what kind of system you are using. So for the continuous system, such kind of bent type you can use. So one of the layers of belt is moving over this one, another layer will be moving through the middle of this one. So that's how actually you can create a different type of systems. Okay. Now, I don't know whether can I get another 5 minutes? So the 3D printing, otherwise I can stop it here.
Please, sir.
Yeah. So then I'll quickly go through you.
Yes, sir.
Yeah, this 3D printing technology. So is another is basically also termed as additive printing. So additive printing means we are creating a food product layer by layer. That's what it is, nothing but. And for example, you are having a pizza. There are actually a number of layers you have to actually prepare. So each layer actually can be put according to your choice. So that means this technology can give you custom specific, nutrition specific, or maybe as per the choice of individuals, one can make. This may be a chocolate creation, this may be a pizza creation, this may be any other food product creation. Okay. However, the task in the 3D printing technology is preparing your inks, basically the puddings which are edible, creation with appropriate viscosity, flowability, and maybe not smudging kind. So that is one of the basic challenge. Okay. So this is the simple overview of a 3D printing. So let's say a kid is thinking of, I want to consume a biscuit in the form of in the shape of a butterfly. So you can think of maybe a 3D modeling can be done of that particular shape. That is actually converted as a G code. This will be transferred to the machine. And this machine actually now can print according to that particular shape, layer by layer. While you are creating these layers, so even the middle layers actually you can have a alternative materials also. For example, you are having some heat sensitive vitamins or maybe heat sensitive bioactives are there that can be kept in the middle layers and again wrapped with another layer so that during your baking, so probably those are protected properly. So that's the main advantage with this 3D printing. So finally, after baking, we can get that kind of interesting shapes with some kind of improved nutrition. Basically, one can target for individual choices. Okay. So these are actually several shapes and colors can be created with, of course, edible inks basically. And these are other kind of shapes which can create. But basically, smooth food additive manufacturing is the alternative name for this one. Then, of course, already Hershey, the chocolate company, so they already entered into this 3D printed desserts. There are actually different types of chocolates which are custom built. These are actually being created by this company. And this 3D printing technology could be a better alternative for the military people, where actually people are staying at high altitudes because they might be having certain desires, might be certain specific needs. So probably one can create individual products based on this 3D additive manufacturing what I can say technology. So printers, like actually the inkjet printing, it's the same technology. Only thing, instead of that artificial ink, we are using edible ink here that will be dispensing through different mechanisms. This different mechanism could be a kind of a simple syringe which will be dropping in drops, or otherwise it could be an extruder. It could be kind of sintering. It could be even kind of electrostatic precipitation, etc. There are a lot of technologies are available for creation of these multiple layers. Overall, the system will be operated through a software-driven cooking, and of course, the 3D printing revolution could be a food revolution in the future. And of course, already these are in existence. Maybe you might have seen in the market. So a lot of cakes are being printed with your own photo or maybe some kind of shapes. This is nothing but a 3D printing only. So these are, of course, different techniques which are available. I'm not getting into details of that one. As I said, so depending upon your softness and dispersibility of the material, one can go for extrusion deposition, maybe drop on demand and deposition. So that way, actually, different kind of techniques can be used. At the same time, the inks can be prepared by simple sugar solution, chocolate, confection, gums, etc. So that way, actually, maybe some kind of nutrients also could be part of it. Okay. So that's in a brief way. And I would like to thank Vice Chancellor Acharya Ranga University, Dean Agricultural Engineering and Technology, Associate Dean Dr. NTR College of Food Science and Technology, University Head Food Process Engineering, and other colleagues of Food Processing Technology, and my beloved students, and my research team at IIT Kharagpur, who had a lot of efforts in developing many of the HPP-based products, which I have, of course, demonstrated today. And IIT Kharagpur for permitting me to join this session, and all the audience for your patient hearing. If you have a couple of questions, I can take. Thank you very much.
Thank you very much, Dr. Srinivas Rao garu, for your elaborate presentation on non-thermal processing technologies. You have explained very clearly with visuals and also the videos on different non-thermal processing technologies like high pressure processing, pulsed electric field technology, ultrasound technology, and pulsed light treatment, including the heating technology. So now the topic is open for any Q&A. You can also pose your questions in the chat box.
Good evening, sir.
Yeah, good evening.
Please
Hello,
introduce.
sir. Am I audible?
Yeah, you are audible. Please go ahead.
Yes.
Sir, can we improve this HPP to the powders?
No, powders actually, since it contains a lot of air embedded, so the products with a lot of air embedded, products
Hello,
having a hot texture, they cannot be applied. But if you are intending to create some kind of tablets, so probably it is possible. But for the inactivation purpose, it is not, because that needs air-free condition. and of course, so that volumetric change, at least a 15% volumetric change, and regaining of that shape. That's also important, because in case of powder, once it gets compacted, probably we cannot get that flowable form. So that's why it is not applicable in case of powders. In case of bread-like products, where a lot of air is embedded, okay, and it cannot be used with bottle filling. Like actually, if any hard surface is there, like cans, bottles, etc., where the pressure cannot be transmitted. So those kind of situations we cannot really take up. Am I clear to your answer?
Thank you, sir. Yes, sir. Thank you very much, sir.
Please, any other questions? Dr. Acharya.
Dr. Rao?
Sir, good evening, sir. Good evening.
Yeah, good evening. I have actually a couple of questions for you.
Yeah, sure, sir.
Yeah, one is, the quality is obviously very important when you go for ultrasound and other, non-thermal technologies. But have you tried, the products like coconut nira, or the ice apple, that is the, tender palm tree
Right, sir.
product, yeah, and of course, your jamun and custard apple, which are highly delicate.
Right, sir.
Have you tried these four, kind of Indian specific produce?
We have not, sir. Actually, there were some couple of similar kind of inquiries, but we have not done. But because initially we were having a certain project mandate on those commodities which I mentioned: mango, lychee, coconut, etc. Subsequently, Dr. Sridevi from ANGRAU only, she worked on sugarcane juice. And aloe vera juice also we worked on, coconut water we worked on. But these commodities are Indian specific definitely, but we have not worked on. Maybe in the days to come, so we will definitely would like to work on those commodities. And not only for HPP, even this can be employed in case of pulse light and ultrasonication. Also, this can be used.
Sir, similar question is there from Jivita Aminana.
Okay.
She is asking that can we use pulsed light for sensitive liquid foods like nira or lemon water?
It can be applied, madam. Only thing actually, if it is a what I can say, radiation transmitting kind of liquid, then no, the efficiency will be better. But if it is having some kind of color, for example, orange juice or maybe jamun, etc., which are having deep colors, in those cases the penetration depth is limited. So probably we may need more number of pulses instead of only 2.5 to 3 pulses in other cases. So the clear liquids like water or maybe sugar juice, sugarcane syrup, etc., even coconut water, any kind of light liquids actually, it can be very well used. But in case of deep colored one, it needs more pulses. It can be used definitely. The efficiency is a bit less. Even on some of the powders also we can use. For example, so one of my students, she is working in sorghum flour self-stability. So with Curtin University, Australia, she is working. We have actually got very interesting results on that, and we are going to publish soon. One more advantage with pulse light is actually it can be made continuous. It can be made continuous compared to other systems. HPP making continuous is difficult, but in case of pulse light as well as pulsed electric, one can make continuous systems. That's the one advantage.
Any more queries?
Yeah, somebody is asking how UV light is different from pulse light in terms of treatment. Actually, this pulse light treatment also, the radiation consists of UV, starting from 190 nanometer to even up to, let us say, near infrared radiation. In case of UV, probably you are using exclusive UVC or maybe UVB radiation. But only thing, the intensity is less. That's why in case of UV, it takes long time to complete the treatment. But with pulse light, it is actually high intensity high intensity light pulse. So that's why it takes less treatment time. Hardly a few microseconds treatment is good enough. But UV actually takes maybe a couple of minutes to complete the sanitation of the surface. But otherwise, actually, both are having UV components. Intensity of light is important in this case. And the source of light also, it is different in both the cases. In case of pulse light, generally we use xenon lamps or maybe quartz lamps. But in other cases, actually, we may be using some kind of gas-based lights. Particularly the UV lamps, these are similar to your tube lights, having some kind of ionizing gases. That's it. Am I clear, sir? Am I clear of this? Was this? I am not very sure.
Yes, sir.
Yeah.
Thank
Can
you,
we
sir.
use pulse light for sensitive liquid foods like Nira and lemon? Definitely for Nira, it is definitely it's a potential technology. Lemon water, of course, it's clear, transparent, and that can be used. Okay.
If there are no further queries, I thank Dr. P.S. Rao for his very clear and effective presentation and also elaborate presentation on non-thermal processing methods or techniques. Thank you, sir.
Thank you very much, madam. Thank you, Sachinand sir, and other colleagues. So for giving me this opportunity to speak in front of the food technology students, it's my opportunity to talk to all of you. Thank you so much.
Thank you very much. Now we shall move on to the next topic, that is intelligent packaging systems for dairy and food products, which is being presented by Dr. P. Narendra Raju, Senior Scientist, Department of Food Science and Technology, NDRI, Karnal. And here I have to inform that Dr. Narendra Raju, it's a little bit disappointment for us to hear his presentation online, because he is having some urgent work to attend at a different place. So he is away from the headquarters now and he is on tour now. So he has given his presentation in a video mode. Now we will see that video. Vimala, can you please post that video now?
Yes, ma'am. First, I would like to introduce the speaker. Dr. P. Narendra Raju is a dairy technology graduate from Osmania University, Hyderabad, and postgraduate in food science and technology from Acharya Ranga Agriculture University, Hyderabad, and holds a PhD in dairy technology from ICR National Dairy Research Institute, Karnal. He received his highest OGPA during his master's program, and he has been mainly working in the area of packaging of dairy products, especially on edible, biodegradable, active, and intelligent packaging. He has published over 53 research papers in journals of national and international repute. And he is also a life member of AFSTI, IDA, DTSI, and currently he is an elected member of Indian Dairy Association, North Zone. And as ma'am has introduced, sir is like on some unavoidable journey. So he has sent his recording, lecture in a recording. So we'll be sharing it now. Thank you. Speakers are the
ఇలాగే వస్తుందా ఓకేనా
A very good afternoon to one and all. On the occasion of the Diamond Jubilee celebrations of Acharya Ranga Agriculture University, I compliment the university authorities, and I'm also proud to be one of the alumnus of the Acharya Ranga Agriculture University of the undivided Andhra Pradesh. I'm happy to share my thoughts on intelligent packaging of dairy and food products on this occasion. I'll be covering on the brief introduction to the United Nations Sustainable Development Goals, food loss and food waste, intelligent packaging and market status, some of the intelligent packaging systems, smart package labels, and I'll try to illustrate the principle of it. The oxygen indicators, which are part of the smart packaging systems used in food industry, time temperature indicators, which are again part of the intelligent packaging systems, and we'll try to look at the elaborate applications of freshness indicators and the recent R&D in this particular area before I conclude. So we all know that all the member countries of the United Nations have a target of achieving the Sustainable Development Goals, and there are 17 in number. Most of you are already aware. However, what we need to understand here is how these Sustainable Development Goals are connected to the food processing industry, and more particularly the packaging industry. Out of this, at least 7 such development goals are related to packaging industry, starting with zero hunger, where processed and packaged foods can help in meeting the food security concerns of the globe, the good health and wellness, which are related to providing wholesome and healthy foods, sustainable cities and committees or communities, which are related to the plastic waste management. Even number 12, the responsible consumption and production leads to food losses and food waste minimization. Climate action, the impact of plastic waste on the climate, especially the life below water, more particularly the role of plastic waste, especially the microplastics in seafood and the corresponding food chain. and the life on land. So these are all, we are all aware of this. However, the current topic, the smart packaging, is directly related to responsible consumption and production. So we will look at what exactly the United Nations has given or defined what is food losses and food waste. To be very particular, if I wish to say that what is food loss, it is related to the production end, and food waste indicates the consumption end. So whatever is happening with regard to on-farm or post-harvest handling related issues, they are considered as losses. And after the processing is done, and whichever is wasted at the end of the consumers, retailers, that is considered as food waste. So smart packaging can address both these, especially in terms of the food waste. Now, food waste, as I said, it could be any fresh produce that deviates from what is considered optimal. You are all aware. The second one, foods that are close to or nearing or even just surpass the best before or expiry date printed on the label, or even large quantities of wholesome food which is unused or even leftover and discarded at the end of use at quick service restaurants or the food service restaurants. Now, another important segment or importance to food waste is, during the last year, the FAO has recognized this 29th September as the International Day of Awareness of Food Loss and Food Waste. So this shows an importance of the food waste and how packaging can minimize it. Now, most of you are aware that food packaging has four major and basic functions. The production function, in other words, the protection, communication, convenience, and containment. Now, if any packaging system that has over and above the basic protection function, they are all considered or termed as active packaging systems, and those which have an additional benefit in terms of communication function are all considered as intelligent packaging systems. So straight away, our current topic leads to those packaging systems which are directly related to communication functions or functions which are over and above the communication functions. Now, intelligent packaging systems include multiple segments. We'll come to that in a short while from now. So the packaging industry is being driven by several factors, and one of the key factors, as you are aware, is the economic trends, demographic changes, retailing trends, convenience food solutions, health awareness, supply chain demands, material science developments, and environment consciousness, which is created among the consumers as well as the other stakeholders in the industry. But the intelligent packaging systems are most related to the supply chain demands of the processing industry. Now, if you look at the top trends in food packaging industry also, recent reports have highlighted the importance of several modern and novel packaging systems, including active packaging, customized packaging, convenience solutions, simplified designs, and also they are also targeting towards the smart packaging and sustainability. The ranking may be different from different agencies, however, these are all the prominent ones which are listed there. So, our smart packaging is also one of the top trends in the current packaging industry. What exactly is smart food packaging? If you look at the global market, in 2022, the active and smart packaging market was estimated at around 12.2 billion US dollars and expected to reach roughly around 30 billion US dollars by 2032, registering a growth rate of about 8.3%. Now, being a hub of two populous nations, both China and India, Asia Pacific region is considered to be the fastest growing market, and also the silicon market being popular in South Korea, and a number of nanoparticles being developed in South Korea and those regions. Even it is considered as the fastest growing market for smart food packaging applications. But if you look at the current trend, North America is the largest one with a number of applications in terms of time temperature indicators, in terms of freshness indicators, in terms of the leak indicators. Now, if we want to explain the concept of smart packaging, this diagram will clearly give you two important options. The one, a label which is placed over the package, and the other one, a label which is placed inside the package. So the external one is in direct contact with external environments like humidity, temperature, sunlight, etc. While the internal one, which is also called as direct smart label, is in direct contact with the internal headspace of the packaged food. So the gases that are emanated or released from the package due to storage or metabolic activity, the headspace gas composition that gets changed due to respiration of a produce, or maybe due to modified atmosphere package systems, etc. And the same is applicable to the processed foods also. Even it could be applicable to the cheese, where the cheeses also respire to a certain extent during ripening, because cheeses are usually stored for number of months to years. So these kind of labels interact with the labels, maybe externally or internally, and they manifest in color changes. These manifestations result in colorimetric changes which are easily visualized by stakeholders in the supply chain. So at the end, you have some indicators which are not directly related to extending the shelf life of the package, but informing the stakeholders and the persons involved in the supply chain about the real-time quality status, so they can take some appropriate or informed decisions. Now, with the increasing use of smartphones and applications of smartphones in across the fields, packaging industry is also not lacking, and you find number of near-field communication systems like Bluetooth, RFID, and other kind of technologies being used in packaging applications. So what is the need for smart food packaging? Because the consumers are demanding long-term storage and preservation of food, and methods which can easily track and preserve freshness and safety. So primarily they are looking for some indices of quality which can reliably inform them whether a packaged product is fit for consumption, for storage at home, for desired duration, or if it is worthy enough to be marketed. So such kind of needs are getting arised, and so people are looking for tools. And as I said, one of the important tool which has come out as a necessity of the frozen food industry is the time temperature indicator. The time temperature indicator is a simple, inexpensive device which can show a measurable and time temperature dependent change that reflects the way a food has been handled and exposed to temperature. In other words, the thermal abuse of a packaged product can be easily monitored and informed by a time temperature indicator. And the principle of operation of TTI could be several, and the principles include mechanical, chemical, electrochemical, enzymatic, or microbial. But one thing is common across all the principles is the time temperature indicator response is irreversible, and it is a visual response. And mostly the intensity of the color change of the label is temperature dependent. So as the temperature increases, the intensity will increase. That is what an ideal time temperature indicator is expected to do. So usually these are most widely used in frozen food applications, but outside food industry nowadays pharmaceutical companies are also using such kind of time temperature indicators to a large extent. These three can be classified The commercial ones can be classified into physical time temperature indicator, chemical time temperature indicator, and biological time temperature indicators. And because these are not directly in contact with the internal headspace but are placed above the package, they are called as indirect smart labels. So this example is a physical time temperature indicator which requires some trigger mechanism, a 3M monitor mark. I just want to mention here, I'm not recommending or promoting any particular brand, but for educational purpose, I'm just citing and showing these examples. So this is a physical time temperature indicator which needs to be pulled. That means some physical action is required where the dye passes from one side to the other side through capillary action. So this capillary action will bring out changes in the color which is not present in the beginning, but as the temperature exposure is monitored and recognized, the diffusion will change. The rate of diffusion will depend on the temperature exposure. Similarly, this is a chemical time temperature indicator, and this contains thermochromic inks which change in color whenever the desired temperature or critical temperature is surpassed. In this case, this is a microbial smart time temperature indicator wherein the color of the smart indicator is changed due to microbial action within this particular color. So you can see here the green color is converted into purple color whenever it is exposed to higher temperature or temperature of critical abuse. So such kind of microbial time temperature indicators could be devised at our own end for our own applications, and one such application I am showing you here. We have isolated some critical microorganisms from vacuum packaged paneer which is spoiled, and the whole purpose is that usually vacuum packaged paneer is subjected to be stored at 4 degrees centigrade or so. If the temperature exceeds beyond 10 degrees or maybe 15 degrees centigrade due to refrigeration losses or due to malfunctioning of the refrigerator on insulation or whatever it could be. So we wanted to know what kind of changes, we want to know if there is such kind of temperature abuse to take immediate measures. So we have isolated some critical microorganisms and tried to develop a prototype to 10 degrees centigrade with visual colorimetric response. You can see here from 6 degrees centigrade, 15 degrees, 25 and 37, the color is totally different. So this is what a microbial time temperature indicator or TTI will indicate the consumer. So the applications of time temperature indicators are many, but usually the indicator development will focus on the activation energy of the spoilage index of the packaged product. A TTI should be within plus minus 25 kilojoules per mole of the activation energy of the deteriorative reaction. For example, if the oxidation is expected in a packaged product when temperature exposure or critical temperature is exceeded, then the TTI should be able to detect that particular oxidative changes. So it should be within that time limit, within that spoilage indicator limit. So these are widely used in the developed nations, and we are also finding it now in pharmaceutical industry in India with some of the applications of TTI in export markets too. The second example is oxygen leak indicator. So we are aware that modified atmosphere packaging is one such important packaging technique where we intentionally change the internal headspace of a package by active means or due to the respiration of the fresh produce by passive means, and the internal headspace gets changed. And due to this, the vapor pressure of the gases which are present inside the pack and which are present externally will have different vapor pressures, creating a gradient. This will ultimately lead to ingress or egress of the gases from inside the package or pumping the external gas into internal environment. So we always depend on the pack integrity, which is a critical thing for the success of any MAP system. However, if you want to check whether a modified atmosphere package system is aptly prepared or done, we need to have some tools. So this is how a MAP system looks. We are aware that there are three different gas composition cylinders, a mixer and a buffer tank, which helps us in storing the desired composition of gas and pumped into the gas tray sealing machines or MAP machines. Now, in this example, you can see that most of the processed foods like dairy products, they don't contain any oxygen in the headspace. I mean, ideally, it should not contain any oxygen for its higher shelf life. So if I pack any of my dairy product with modified atmosphere gas and want to ensure that there is no ingress of oxygen from external environment, then I need to have the pack. So commercially, there are number of oxygen leak indicators which are placed, but these are mostly imported. And thanks to the efforts from the industry, from the government and the policy decisions, now we have the indigenous oxygen indicators or the indigenous oxygen sensors developers inside our country also. So in one such application, we have used electrospinning technique to develop an oxygen indicator which can bring out color change and give the real-time status of oxygen leak or oxygen absence in processed packaged dairy products. You can see here the color change in presence and in absence of oxygen. Third segment is the freshness indicators. Freshness indicators are nothing but smart labels. In other words, they are the direct labels which are in direct contact with the headspace of the packaged product. You might have seen these kind of conventional labels and shrink sleeve labels earlier. But a smart label or an intelligent label is a label or an indicator which has an ability to track the product, sense the environment, and inform the manufacturer or for that matter anyone in the supply chain about the condition of the product. And here the condition means the real-time quality status of the food product. So it could be a chemical sensor or a bio sensor, and again it's a visual one. So in this illustration you can see that a packaged product which is having the direct smart label, this freshness indicator placed inside the pack, will get interacted with the gases that are released inside the product, and they bring out or manifest in some color changes. These color changes, which are different, I mean the color will be different in the beginning, and at a later stage when the accumulation of these gases are done, the color change will be different. So that is visually noticed from outside the package itself without destructing the pack, without need of any particular analyzers. So the quality indices could be total volatile basic nitrogen, carbon dioxide, ammonia, ethylene, or even the ethyl alcohol and other volatile organic compounds. So the need for freshness indicators is also similar to the other packaging needs. Nothing more to mention. However, the indicator fabrication required certain prerequisites, and we need to understand, because food products are diverse and their spoilage mechanisms are also diverse. So we need to understand what is the key spoilage volatile marker, and then we need to understand how these markers interacts with different kind of indicator dyes, colors, chemicals, so that the color change can be brought out. And then the support matrix, where you want to place it, either in the form of an indicator sticker or label. Maybe you want to use the paper, you want to use an electrospun mat or a plastic or even a spin coated material. So that has to be decided. So these are some of the prerequisites for fabricating or developing a freshness indicator. So for understanding the key volatile markers, you need to go with the GCMS technique to look at what are exactly are the volatiles. So such kind of volatiles were first published in the year 2006 for volatile compound for the freshness indicator of fish. So commercially, you have one such example in New Zealand in the name of Ripe Sense, where the ripeness of status of fresh mangoes were depicted. Research publications are available with regard to the packaging of guava and apples, golden yellow apples, as well as the normal ones. In the dairy segment, you have infant milk powder formulas, and the key volatile compounds what they have targeted is carbonyl compounds, primarily the aldehydes, ketones, and some of the carboxylic acids. So, with regard to the Indian context, none of the these are currently using any of these freshness indicators, but looking at the diverse needs of the Indian dairy industry, we started working on this particular aspect of addressing the freshness indicators for export markets, especially for the traditional dairy products. We all know that dairy products are commercially packaged in this form, in all available packaging forms, but none of them has any smart labeling or smart packaging tools adopted. So in this example, you can see that how a freshness indicator which is placed over the package, which gets changed due to the accumulation of volatile compounds inside the pack, and then these kind of indicators with different dyes, the color changes are clearly visible. Now, when it comes to an external package or a secondary package, you can see how we can pack them. We can have our own kind of design to inform the consumers, and the company can decide what kind of visually a guide when to match the color of the indicator which is present inside and with that with the guide that is present on the pack. So fresh, good, risky, spoiled, and such kind of things like good, spoiled, or even ready to consume or ready to about to be discarded. So such kind of nomenclature can be used. So these are the indicators which are developed. Globally, now you find that the indicators are not of a simple one, because in the earlier one it was dependent on a few applications and volatile compounds. Here it is in some of the non-vegetarian foods like beef and meat, they started using multiple indicators. So these multiple indicators are clear here, dual indicators. Also, people are now integrating 3D printing and smart and active packaging for the benefit of for fabricating such kind of smart tools. So the scope of developing smart tools is enormous. So in the end, I wish to conclude by stating that the real-time quality status will not only help us in meeting the sustainable development goals by reducing the food waste and food losses, they also give the status will be in will help us in taking an informed decision choice to the consumers. The expected predicted shelf life, which can supplement or complement the expiry dates present or printed on the package label. More importantly, it can also help in the brand loyalty whenever we are trying to export or even for the domestic markets in the coming days. So ultimately, it brings better returns to our producers, the farmers. So thank you very much. I'm sorry I couldn't personally make it. I'm sending you a recorded presentation as I'm traveling, and it was not possible for me to join at 3:30, which is the scheduled time for me. Thank you very much, and I thank the organizers, the Associate Dean and the Vice Chancellor of Acharya Ranga Agriculture University for giving me this opportunity to share my thoughts on this occasion. Thank you.
We thank Dr. Narendra Raju for his elaborate presentation on packaging system, that is intelligent packaging system, which is required for most of the food products and especially with the dairy products. And though in his absence we cannot pose any questions, but I request Dr. Vimala to give his mail ID. If there are any queries, they can ask him directly. Vimala, is it possible to share his mail ID?
Madam, sir will be joining. Madam, he is joining.
Oh, thanks.
Yeah, he is joining. So Dr. Narendra Raju sir will be joining. Like he's joining now. The participants can ask the questions directly to Dr. Narendra sir.
Hello. Madam, good evening.
Good evening, sir. Very nice to see you. Just now we have listened to your video presentation, and it's very interesting also regarding the food packaging, that is the smart packaging system. And I have my own doubts, sir. But is there any uniform freshness indicators which are accepted throughout the globe for any product?
At the outset, I'm very sorry, ma'am, I couldn't join live for the presentation, but I'm really thankful for giving this opportunity. And I've just heard your question. Looking at the ability of the freshness indicators, there is no one particular universal freshness indicator. And the reason is the spoilage mechanism of different food materials is totally different. For fish, it could be different, and within the fish, among the different species of fish, it could be different. For fruits and vegetables, we always think of the ethylene, but we also have other carbonyl compounds. So once we know that one carbonyl compound has been used for developing a freshness indicator of a particular food, probably we can adopt it for other food material, but not straight away use it. Maybe we need to have some tailor-made. Yeah.
I'm asking only for a particular food product. Is there any uniform freshness indicator? It's not for all products.
Yes, ma'am. There are a couple of examples with regard to the freshness indicators, especially starting with the ethylene for the golden delicious apples. Yes, ma'am. Any other query? Am I audible, ma'am?
Sir, good evening, sir.
Yeah, good evening.
Thank you very much for joining in time.
Sir, is it possible to improve that intelligent packaging at laboratory scale levels?
Implementation, right? Yes, it is totally possible for implementing intelligent packaging systems at the lab scale.
Hello.
Yeah, I'm able to hear you, please.
Yes, sir. Sir, is it available to improve such type of intelligent packaging at laboratory scale level?
Yes, if you don't ask for a particular food material, we already are using such kind of intelligent packaging systems and thermochromic inks in microbiology lab. See, if you are autoclaving some media, petri plates, or even some food material, and you want to know whether the particular product has been subjected to 121 degrees centigrade for 15 minutes and at 15 lbps pressure, so we have certain inks which will, reflect their new color only when such temperature and time is achieved. So we already have that kind of intelligent packaging systems, intelligent systems at lab scale. But these kind of intelligent systems for food products, we know the know-how, so we can easily adopt it. That's what we have been doing. At giving my own example, we have developed this freshness indicators for about 7 different dairy products. And we started showcasing these indicators at different expos, including the Agriculture Science Congress, which recently held at Cochin, and also at the G20 meetings held in Hyderabad, Varanasi, and other places. So yes, it can be carried out at lab scale also.
Thank you, sir. Thank you very much.
Yeah, welcome. Any other query, ma'am?
Yes, sir. One more student is there, sir.
Yeah, please.
Good evening, sir.
Yeah, good evening.
Sir, can you ED, PD, biodegradable can be 3D?
3D biodegradable materials.
Sir,
Right. We can develop three-dimensional biodegradable materials from different polymers, and there are certain technologies already available. So people are working on different 3D printed closures, 3D printed articles from bio-based materials. Yes, it's being done, but not on a commercial scale.
sir. Thank you, sir.
Yeah, welcome.
Any more queries?
Yes, please.
Please come forward if there are any more queries, because he is waiting for us on his way to some other place.
Sorry, ma'am, I couldn't hear.
No, I'm telling that you are waiting for us, no, for queries. You are on your journey to some other place.
Sir, there is one question in the chat box. That is
Yeah.
generally in smart packaging materials are made by using synthetic dyes or some chemical compounds like organic chemicals. If these materials migrate into food, causes hazards.
Yeah, I have just read that question also. There are certain concerns about the hazard of the additives that we use in synthetic packaging, these kind of smart packaging materials. But usually they are not supposed to be in direct contact with the food material. So there is no major harm or danger. But still, first of all, we need to understand how to develop such kind of packaging tools. Then we need to address the safety issues. So people have been started working on using the food waste ingredients, such as the anthocyanins from food waste, the fruit and vegetable waste, etc. So instead of synthetic dyes, they are going with the natural dyes also. So people are working. So we are in the process of evolving such kind of tools for smart packaging, smartly packaged food products. Hope I answered his query.
Yes, sir. Yeah. So one more question. It is any commercial applications in India are available?
Frankly speaking, for processed packaged food products, we don't have even one particular example from India, but yes, from other countries, we do have. In India, we have a good number of applications for pharma applications.
Thank you, sir.
Thank you very much, madam.
So now I request Dr. Vimala to propose vote of thanks formally. So before presenting the vote of thanks, I request Dr. Acharya sir to conclude the webinar. Sir?
Am I audible to you?
Yes, sir.
Yes, sir. Yeah,
Yes,
good
sir,
evening.
yes, sir.
Very good. Good evening, Dr. Narendra Raju. Are you there?
Yes, sir. I am with you, sir.
Yeah, very good. Very good. Very nice to see you. I'm very glad. It is a very outstanding presentation. I recollect that, when we were together in FSSI for the meetings, it's glad that, you made it today, despite of your, some urgency, meetings and all that. It's been wonderful. One question I have, just, quick question is that, normally the packaging cost is kind of sometimes 1/4 to 1/30, 25 to 35% of the total cost of the product sometimes. In that case, when you go for smart packaging, obviously the cost is going to go up a bit. So can we really apply this for a kind of a medium to low value products?
Sir, frankly speaking, the cost.
Hello.
Connected అయితే.
Okay, disconnected, is it?
Please wait for some time.
Sir, the
Yeah.
So they just add 1 to 2 rupees per pack, sir. We have calculated the cost of some of the indicators also. So I don't think that they are adding much cost, but on a commercial basis, because they invest on the technology in the beginning, by the time the technology is popularized, it may be costly in the beginning.
Yeah, true. Thank you. Yeah, that's good. Especially for dairy, there is a good scope, especially for the freshness indicators, because most of the indigenous Indian dairy traditional products have an excellent flavor, but they tend to lose out with time. So this freshness indicators can be of great help to some of the indigenous dairy products. That's a very good work. I think you are doing at NDRI Karnal. So we compliment from our college. Thank you very much, Dr. Narendra Raju.
Sir, thank you very much, and I really thank you all, especially the Honorable Vice Chancellor Madam, Associate Dean Madam, and you all, your team, for giving me this opportunity to be part of the Diamond Business for the. Thank you.
Yeah. Thank you very much. I just take few minutes to conclude. I think we had a wonderful webinar this afternoon, the one with Dr. P. Srinivasa Rao from Professor. I think there is an echo. Please, somebody has to mute it. Yeah. Two professors, one from IIT Kharagpur, Dr. P.S. Rao, who is our alumnus, illustrious alumnus, and the other one is Dr. Narendra Raju again, and another alumnus from our university, both of them. And I think from the P.S. Rao's presentation, it's really, he has covered a lot of non-thermal processing technologies, and he started with main focus is on HPP. HPP, he covered quite detailed, in a very detail, right from, the components of a HPP system, and the shelf life, the issues, how much pressure has to be applied, and the challenges, especially for some of the Indian-based fresh commodities, how to retain the quality. The main key point is that at a low temperature, when you treat them, we retain the quality. That's where these HPP and other non-thermal can help a lot. And he has also covered not only HPP, but also went on to cover the pulsed electrical field, where it needs about 70 kV per centimeter of voltage for a few microseconds, so that the quality will not be affected. And he also covered about the high electric field pulse treatments also. And then he threw some light on how air bubbles or gas bubbles in a product can offer challenges for taking the use of the pulsed electric field. And ultrasound is another technology. He has also covered that, mainly the sono extraction and other things. And the take home message is definitely, there is a huge potential for the non-thermal technologies, because the consumer is getting more and more quality conscious, and they're willing to pay higher price as well. So in that view, even 3D printing is really an excellent promising technology, like the computer numerically controlled CNC machining, which is there in mechanical engineering, but now it has come to the food processing as well. Very convenient. Any kind of shapes can be generated with all the different layers of the chocolate or whatever. And so that was the main message, is that all the new technologies, especially the non-thermal ones, are promising. Some of them are even getting commercialized also, but there is still a lot of research opportunities in non-thermal processing of the different food products. So that was amazing. Then we have the another speaker we have just finished, Dr. Narendra Raju. He has mainly covered on the intelligent packaging of the dairy and food products. He started with the outlines of the presentation. Then he went on to talk about the oxygen indicators, time temperature indicators, freshness indicators, and then also he covered about the sustainable development goals of the United Nations, which are about 17 number. And then 7 are really interestingly very close to, are very relevant to the packaging. And we all know the microplastics in seafoods and lot of damage that they are causing. So I think then he covered mainly on the different indicators like leak indicators and the types of indicators and the smart labelings, both direct and indirect type, and also the physical time temperature indicators, chemical, biomicrobial, all of them, how they work, how they are useful, and especially the oxygen leak indicators are useful in MAP, modified atmospheric packaging, which where the freshness is very, very important. And of course, the fruit ripe sensors are also there in New Zealand. He was telling the example of the apples. And then lastly, he kind of closed with the smart packaging for tools for dairy products, particularly for the fresh indicators, mainly for the Indian traditional Indian dairy products. And then 3D printing as well is covered. So again, in his epilogue, he has clearly mentioned that the intelligent packaging is again a very exciting area. A lot of things to be done, a lot of research opportunities for a scientist who wish to pursue that particular area of research. So I think we have been having a great information receivable from the audience and participant side in this webinar. So with that, I conclude that we have got a good exposure of the current trends in both the non-thermal processing technologies and also the smart packaging or the intelligent packaging. So that's a feast to all of us, I think, from our angle. We thank before the farmer water thanks host. I compliment from my side. I know them, both of them are my students actually. So it's I am very happy, feel proud that they are doing a very good work. So thank you for the organizers for giving me this opportunity. Thank you very much.
Thank you, sir. And really, it is a good opportunity to have the presentations from our alumnus. I request Dr. Vimla to present the
Thank you, madam. I take this opportunity to propose vote of thanks for this webinar on advances in food technology, which is actually been organized on occasion of ANGRAU Diamond Jubilee celebrations. So I first of all thank the Vice Chancellor of the University, Dr. R. Sarada Jalakshmi Madam, for accepting the webinar and approving it. I also thank Dr. A. Vishnuvardhan Reddy sir, Special Officer for the University, for having been conceiving this idea of conducting webinars in the Golden Jubilee Diamond Jubilee celebrations. Also, I thank Dr. G. Karunasagar Garu, in charge of Principal Investigator of IDP ANGRAU, for providing us with the funds timely and also helping in every aspect of conducting the webinar. I also thank Dr. A. Manigaru, Dean, Faculty of Agriculture, Engineering and Technology, for encouraging us at every part of conducting the webinar. I take this opportunity to thank the speakers of today, Dr. P.S. Rao sir, who has been accepted our invitation and also joined the webinar, and I especially thank him for explaining about the non-thermal methods of food processing in a very broad way. Thank you, sir, for taking time and talking to our students and presenting and giving us a great presentation. I also thank our senior and who happens to be my senior and senior scientist of Department of Food Science and Technology, NDRI Karnal, Dr. P. Narendra Raju sir, for joining us in this session. Actually, even though in spite of his busy schedule, after sending the audio video presentation, the recording of it, sir has also joined for the webinar and interacted with the participant. Thank you, sir, for accepting the invitation and also joining us in the webinar. I thank the chairman of this session, Dr. Y. Radha Garu, our associate dean, for her continuous guidance and also her complete overall inspection over this webinar from day one till the end. And I also thank Dr. C.H.U. Satyanarayana sir, the vice chairman of the webinar, who has given us a huge support in conducting this webinar, starting from selecting the speakers contacting them and getting all their information and arranging the speakers for the webinar and also encouraging us in every part. So I thank our student staff of our college, Dr. NTR College of Food Science and Technology, and also all the teaching staff from Faculty of Agriculture, Engineering and Technology, and especially to ANGRAU web portal for giving us the live YouTube stream of this webinar. Thank you one and all. And I also thank the participants. I would like to bring here that we have got the participant from 25 different colleges over the country apart from our students. But unfortunately, few have joined. Some 18 colleges students have joined. And I'm very thankful for making all the staff of that particular colleges to allow their students to join for the webinar. Thank you one and all. Thank you, madam.
Now the Zoom meeting for this webinar is closed. Thank you all.
Madam, 1 minute. We will be posting that feedback link here. So all kindly fill in the feedback form and we will be sending you the e-certificate shortly. Thank you.
Thank you.
Thank you, madam, and thank you, sir. So thank you all faculty colleagues and students. So, thank you.
If there is no issue, can all the participants switch on their video so that we can take a photograph? Meanwhile, when the feedback form is shared. It is already shared in YouTube where it is live stream is going on, and few of the participants have also watched the webinar from YouTube. Yeah, the feedback form is shared. So kindly fill the form. Thank you, everyone. Feedback. 2 minutes on. Stop.
After submitting the feedback form, you can leave the meeting. Okay, thank you.